my name is Abhishek Jain and welcome back to the part 3 on how to build a sentiment analyzer and a document classifier with the natural language processing library written in Python and known as Nltk. Before continuing with this video, I would highly recommend you to watch part 1 and part 2 because we are going to continue from the coding part which we had already done in part 1 and part 2. So let's quickly do the recap what we had covered and see up to what point we have coded, right? So if I just run the code which you can see on my screen, okay, so let me just run it and see what it is doing. Because so as you can see on my screen, what it is doing is it is only checking for the plot, and that seems to be the first word in all the documents, right? So it means that we have something wrong here, right? So it's not like wrong. I just wanted to check whether this feature is working fine or not. So if I just remove this break, then let me just run this one more time. Let's see. And one more point which I wanted to do here is let me just print out the first one, not the complete feature set. Now you can see on my screen, now for each and every word, for each and every document, it is now checking for each and every word which we have in that particular document, right? So now it looks good. Let me just cancel this. Okay, what next? So let me just comment this out. So what we had done, we just picked the first 100 as a test data set, and the rest of the document, rest of the documents feature we are just using as a train set, right? So now what I'm gonna do is, now the next thing which we have to do is we have to define which classifier we want to use. Since it's a text data and NaiveBayes seems to be working fine when it comes to classifying a text data, especially when we have only two options like yes and no, or here we have negative feedback or a positive feedback or a review, right? So what Nltk provide us, so let me just import from Nltk. I'm just gonna import a classifier known as NaiveBayes classifier. Okay, so that is how you can just import that, and I can just mark it as NBC. Okay, now what next we have to do, we have to define our classifier, a variable, and in this we have to do NBC, and then we have to use a train function, and in this train I have to just pass the train data set, and in our case that is a string set. Okay, so now in this way our NaiveBayes algorithm is actually trying to understand what kind of data we have inside the train set. So if I just go back, what we had done is, if you just see that it is just checking whether the given word is whatever the feature we have 2000 first 2000 most occurring words across the document, and we are just checking whether that particular word is present in each document or not, and based on that we are just marking as a true and false, right? So based on this information, our NaiveBayes try to understand what all words to be considered when it needs to decide whether the words which we have in a document is negative or positive. So that is how this train set is helping NaiveBayes classifier to make himself understand how to distinguish between negative and the positive, the review. So the next thing is, what we have to do is we have to just check the accuracy. So how can we do the accuracy? But before that, let me just do one more thing. Let me, because that's the reason I just utilize Nltk, because it has a lot of features which we usually use to just understand what exactly going on. Similarly, we have a classifier show underscore most underscore informative features, and you don't need to worry about all these stuff. And what you can do is, so for example, let me just do one thing for you. Let me just show you how can you extract all these information, like what all functions and what all things each and every module is having, right? So if you have Python programming background, you will easily know that how you can do it, but let me just do it for you. See, and then print dir nbc. Okay. So now you can see this inside this NBC what we have used this train, right? Similarly, I just try to use show most informative feature. So that show most informative feature will tell us, okay, what all actual words, our classifier or algorithm is depending upon heavily, right? So let me just run this, save it and run it, and once this gets done, then we just gonna see how we can calculate the accuracy with the test set which we have. Oh, so let me just close it here, and let me just remove the print statement which we have here, so that we can just speed up the process a bit, I think. And yeah, so this show underscore most informative feature will tell us what all words and what kind of information it is providing to our algorithm. So how the model is deciding whether it's positive and negative, and that we can just quickly see. Oh, classifier again! I just made a mistake, and this is a simple one to fix. You can see on my screen. Let me just see what is the most informative feature for our algorithm. We have singers, turkey, poorly, wasted, and underwood, right? And if you will see here, if it is having a singer, then it is having 6.4 times more probability that it is going to be the positive feedback. Similarly, if we have having a poorly or wasted, we can see that it's a 6 times more possibility that document or the review is the negative, right? So now how can we have a lot of ways through which we can change all these stuff, and we're gonna see how we can do that. But first, let us utilize the other another module which we have in our NLTK, and that is known as from NLTK import classify. Okay, and this classify as calculation. Okay, and how can we do that? So for doing that, dot this has accuracy function, and this accuracy basically require our classifier on which we have trained our module, followed by the test set which we have, right? These are the two things which we have to pass here, and then we can quickly put the print and see what exactly the accuracy is. Now you can see on my screen, we have achieved 0.79, which is 79% of accuracy based on the test set. And quickly, what we can do is we can just quickly write a small code, what we can do, and we can see that what all documents are being, correctly identified, and what all not identified as correctly, and how can I do that. And for that, I've already write a small code, and let me just bring that in here. And if I run this, now